Hey, what if I told you that one of the scariest things in algebra is actually something you've known how to do since, like, grade school? Seriously, today we're going to pull back the curtain on rational expressions. And I promise, by the end of this, you're going to see just how simple they really are. So, let's dive right in.
Okay, you see something like this pop up on a test, and what's the first reaction? Probably a little bit of panic, right? I mean, you've got variables, you've got exponents, and it's a fraction. Yikes. It's totally designed to look like some impossible puzzle. But trust me, we're about to crack the code. But here's the big secret, the thing they don't always tell you. You already know how to solve this. For real. If you can simplify a basic fraction, you've got all the tools you need. All we're doing here is adding a few letters into the mix, but the fundamental rules, they don't change one bit.
So, here's our game plan. First, we'll unmask these fractions in disguise. Then, we'll cover the golden rule, simplifying. After that, we'll see how to multiply and divide them. We'll even tackle those crazy-looking fractions inside of other fractions. And finally, you'll walk away with a brand new math superpower. Let's do it.
All right, let's kick things off with Section 1, Fractions in Disguise. Time to see what's really going on here.
Okay, so the official term is rational expression. Sounds kind of fancy, right? But don't let the name fool you. All it means is a fraction that has polynomials in it. You know, expressions with variables and exponents. And fun fact, the word rational comes from ratio. And what's a ratio? Yep, just another word for a fraction. See? Not so scary. Now this. This is where it should all click into place. Look at the left, 6/8. We all know that simplifies down to 3/4, right? You just divide the top and bottom by 2. Easy. Now look at the right, 3x over 4x. It's exactly the same logic. The x is just a common factor, just like the 2 was in 6/8. So what do? We cancel it out. And what are we left with? You got it, 3/4. It's the same principle, just dressed up with a variable. Okay, so now that you see they're basically the same thing, let's get to the most important skill you'll need. This is the golden rule. It's all about simplifying. If you can master this, honestly, you can handle pretty much any rational expression they throw at you. And it's really just a simple two-step process. First, you have to factor everything. Factor the top and factor the bottom completely. This is the most important step because it's like breaking the expression down into its Lego bricks. It lets you see all the individual pieces. Then, step 2, you just cancel out any matching pieces, any common factors that you find on both the top and the bottom. That's it. Hey, look who's back. Remember this scary-looking thing from the start? Well, it's time for a rematch. Except this time, we've got our two-step rule, and we are ready to go. So step 1, let's factor. The numerator, x squared minus 9, that's a classic difference of squares. It breaks down nice and easy into x minus 3 times x plus 3. The denominator, x squared minus x minus 6, we need two numbers that multiply to -6 and add to -1. That's got to be x minus 3 and x plus 2. And look at that. By breaking it down, it already looks way more manageable. And now for the satisfying part. Step 2, cancel. Do you see it? We've got an x minus 3 on the top and an x minus 3 on the bottom. That's our matching piece. So, just like we would with numbers, we can cancel them right out. Gone. And what are we left with? Just x plus 3 over x plus 2. I mean, look at that. We went from that intimidating beast of a problem to this simple, clean answer. That right there is the power of simplifying. It's all about finding the simple truth hidden inside the mess. See? You're already getting the hang of this. Now that you're a pro at simplifying, we can build on that. It's time to see how we can put the pieces together by multiplying and dividing these expressions. The good news is, multiplying these things is maybe the easiest part. It's exactly what you'd expect. You just multiply the tops together and multiply the bottoms together. That's it. Top times top, bottom times bottom. The only trick, and you're already good at this, is to remember to factor and simplify when you're done, just in case you can. Okay, so what about division? Well, to do division, we just need to know one little word, reciprocal. It sounds technical, but it just means to flip a fraction. That's all. The reciprocal of 2/3 is 3/2. The reciprocal of x over y is y over x. It's just the flipped version. And this one tiny idea is the key to all division problems. And that leads us to this classic, easy-to-remember rule you may have heard before. Keep, change, flip. When you're dividing fractions, you keep the first fraction exactly the same. You change the division sign to a multiplication sign, and you flip the second fraction. You use its reciprocal. And poof, just like that, it's not a division problem anymore. It's a multiplication problem, and you know exactly what to do with those.
Okay, deep breaths. Time for what feels like the final boss, the complex fraction. Yep, we're talking about fractions that have other fractions inside them. They look absolutely wild, but I'm telling you, once you see the trick, they're actually kind of fun to solve. So yeah, what on earth do you do when you see something that looks like this? It almost looks like a typo, doesn't it? A fraction bar on top of another fraction bar? But believe it or not, this is a totally normal, even useful way to write things in more advanced math. So, how do we untangle it?
Here it is, the big secret. That main fraction bar, the big one in the middle, it just means divide. That is literally all it means. So this whole complex fraction is just a sneaky way of writing the top fraction divided by the bottom fraction. It's another disguise. Are you seeing a pattern here?
So, our game plan for tackling these monsters is super simple. 1. Rewrite it as a normal division problem, side by side. 2. Use our good old friend keep, change, flip to turn it into multiplication. And 3. Simplify if you can. Notice something? You already know how to do every single one of those steps. There's nothing new here.
And just like that, you've done it. You can simplify, you can multiply and divide, and you can even tame the dreaded complex fraction. Which brings us to our last section, your new math superpower. So, why does any of this actually matter?
Let's just quickly recap the key takeaways. Number 1, rational expressions are just regular fractions wearing a fancy algebraic costume. The rules are the same. Number 2, when in doubt, factor. Factoring is your best friend. It's the key that unlocks everything. 3, division is just multiplication in disguise. Just flip the second guy and you're good to go. And 4, a complex fraction is, you guessed it, just a division problem in disguise. The big lesson here is that things that look complicated are often built from very simple ideas. So why am I calling this a superpower? Because this skill goes way beyond your next math test. Being able to take a complex ratio and simplify it, well, that is a core foundational skill for calculus, for physics, for engineering, for computer science. If you have any interest in those fields, you're not just learning a math problem. You're learning a fundamental tool you'll use to solve actual, real-world challenges. At the end of the day, what you've really learned is how to look at something that seems messy and complicated and find the simple, elegant solution that's hiding inside. And let me tell you, that's a way of thinking that will help you everywhere, not just in a classroom. So I'll leave you with this question. Now that you know how to simplify the complex, what problems are you going to solve next?